Dear students, welcome to s.mathguru classes. So we solved some problems about Lagrange method of multipliers of first order partial differential equation. Now we consider the remaining problems. Solve y minus z into p plus z minus x into q equal to x minus y. So we know this capital P small p capital Q small q equal to R, then auxiliary equation is dx by capital P, dy by capital Q, dz by capital R. This is our auxiliary equation. So in this problem, we get this is our capital P, this is Q, capital Q, and this is capital R. Solution: the auxiliary equations are dx by y minus z, dy by z minus x, dz by x minus y. This one. This is number 1. Now we choosing the multipliers in such a way that the denominator must be equal to 0. So choosing 1, 1, 1 as multipliers, each fraction of 1. This equal to 1 dx plus 1 dy plus 1 dz divided by, if you multiply by 1, then y minus z, multiplying by 1 z minus x, multiplying by 1 x minus y. So we get dx plus dy plus dz by 0. This 0. Therefore, dx plus dy plus dz equal to 0. We integrate dx integration dy integration dz equal to 0. This implies integration dx means x, dy means y, dz means z equal to c1. We get one solution, x plus y plus z equal to c1. Again choosing, so here x is absent, here y absent, here z absent. Again choosing x, y, z as multipliers, each fraction of 1 equal to x dx, y dy, z dz by x into y minus z, y into z minus x, z into x minus y. That means we multiplying this one by x, this is y, this is z. Here also x, y, z. So this implies x dx, y dy, z dz. This is xy minus xz, yz minus xy, zx minus yz. We get this one. And this equal to x dx, y dy, z dz by 0. So denominator equal to 0. Therefore, we can write x dx plus y dy plus z dz equal to 0. So if we integrate both sides, we get this. So integration x dx means x square by 2. This is y dy means y square by 2, z square by 2, c2 by 2. Constant is c2. So we get x square plus y square z square equal to c2. So we get, this is second solution. So what we get, we know if u equal to c1, v equal to c2, these two are solution, then required solution will be f of u comma v equal to 0. This is our required solution. So we get, therefore the required solution is f of, first one is x plus y plus z, second one is x square plus y square plus z square equal to 0. So we get this equal to 0, and this is our answer. This is the answer. Very easy and very interesting. Another problem. Solve the general solution of the equation y plus zx into p minus x plus yz into q plus y square minus x square equal to 0. Now, here given that y plus zx into p minus x plus yz into q, this can be written x square minus y square. If we taking right hand side, x square, this is y square. Again I recall the main formula, p small p, q small q equal to r. Then auxiliary equation is dx by capital P, dy by capital Q, dz by capital R. These are auxiliary equation. So here this one P and minus this is capital Q and this one R. The auxiliary equations are dx by y plus zx, dy by minus x plus yz, and dz by x square minus y square. This is capital P, this one is small capital Q, this one R. Dx by P, dy by Q, dz by R. This is number 1 we consider. Now we choosing the multipliers in such a way that denominator must be 0. Choosing x, y minus z as multipliers each fraction of 1 equal to, first one is multiplying by x dx, next y dy minus z dz, and this is x into y plus zx minus y into x plus yz, and this is minus z into x square minus y square. We get this, and if we calculate this one, x dx y dy minus z dz, this xy plus x square z xy y square z zx square plus y square z. So xy cancel, x square z cancel, and y square z also cancel. So what we get? We get x dx plus y dy minus z dz by 0. We get denominator is 0. If denominator 0, then we can write x dx plus y dy minus z dz equal to 0. We integrate both sides, y dy minus integration z dz equal to 0. We integrate, this is x square by 2, y square by 2, z square by 2, c2 by 2. We get this. And multiplying both sides by 2, we get x square plus y square minus z square equal to, this is c1, not c2. First solution, this is c1. We get first solution, this one. Again choosing next target, again find denominator is 0, again choosing yx1 as multipliers, each fraction of 1. So we multiplying this one by y, this is x, and this one by 1. We get y dx plus x dy plus 1 dz divided by, and y plus zx minus x plus yz plus 1 x square minus y square. So numerator multiplying by x, this is y, this is x, and this one 1, and denominator also we multiplying this. So this equal to y dx x dy dz y square plus xyz minus x square minus xyz plus x square minus y square, and this equal to y dx x dy plus dz by 0. If denominator 0, then we can write y dx plus x dy plus dz equal to 0, and this can be written as dxy plus dz equal to 0. This and this, because y, this is dx, this is x dy. So we can write in this way, and if we integrate this, we get xy z equal to c2. Therefore, the required solution is f of x square plus y square minus z square comma xy plus z equal to 0, and this is our final answer. This is the final answer. These are very interesting solution. Problems also interesting. These are nothing, just practice. With practice you can easily solve this problem. So I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, please subscribe my channel and click the bell icon. Thank you.